Lesson 10.2, Combinations. In Lesson 10.1, we talked about permutations when we were ordering objects. In Lesson 10.2, we're going to talk about combinations. Combination is a selection of R objects from a group of N objects where the order is not important. In other words, we're going to look at some examples here with playing cards. When you're looking at a hand of 5 cards and you're playing a card game, it doesn't matter which card you received first. So order is not important. We just want to know overall the 5 cards that were chosen for you. Or you could think about it in terms of representing your class as class officers. Maybe we choose 5 people to be the class officers, but the order does not matter in which they are chosen. We are just selecting 5 people out of a group of 120. Combinations of N objects taken R at a time. Very similar to permutations, we have a formula here for combination. The number of combinations of R objects taken from a group of N distinct objects is denoted by NCR and given by the formula here. We can do this right on our calculator again, just like we did before, and for combinations, that's probably the easiest way to do it. Let's look at an example. Example 1. A standard deck of 52 playing cards has 4 suits with 13 different cards in each suit. Letter A. If the order in which the cards dealt is not important, how many different 5-card hands are possible? So in other words, N is going to be 52 because there's 52 cards in a deck. And R is going to be 5 because in whichever game we are playing here, there are going to be 5 cards dealt. So I'm doing a combination because the order is not important of 52 cards, choose 5. So to do this on our calculator, actually I'll show you how to write out the formula. It would be 52 factorial over 52 minus 5 factorial times 5 factorial. We can do this right on our calculator, much the same way we did permutations on the calculator. You're going to type in your 52, go to Math, over to PRB, and select the NCR button. After you select that, you hit the 5 and enter. And we see that there are possible 2,598,960 cards. Now in letter B it gets a little bit more difficult. This is kind of going to lead into what we are doing next, but we'll take a look at this one first. In how many 5-card hands are all 5 cards of the same color? In other words, out of these about 2.6 almost million hands, how many of those are all red or all black? So for that to happen, 2 things have to happen. The first thing is you must choose one of 2 colors. The second thing that has to happen, you must choose 5 of 26 that color. Now let's talk about where these numbers are coming from. Choosing one of 2. There are 2 colors in any standard deck of cards. There's red and there's black. So the first thing that has to happen is we're going to choose 2. Of 2, we're going to choose 1 color. So it may be black, maybe red. And, which is what we're going to learn next, when you have 2 events and both have to happen, we need to multiply these combinations. So I'm going to take combination of 2, choose 1, and I'm going to multiply that by choosing 5 of 26. So where does the 26 come from? If half of the deck is red, there are 26 cards. Half of 52 is 26. So in other words, out of the 26, after I chose the 1 color, there's 26 cards left, and I'm going to just choose 5 of them. It can be any 5 cards. When I put these into the calculator, again, I can put this in using the Math PRB and choosing the combination button, and then I can multiply that by this combination. When I do that, 131,560 hands are either all red or all black.